Well, g'day, Max here again. Welcome back to the shop. So this will be part 3 and the final in our 3-part series of our D-grade drafting and design 75mm machinist clamps. So we're just going to hook straight in for where we left off at the last video. And they still turn. Right, that's those parts complete. Next 2 parts, we have to make 2 of these pins here, and they have the thread going through for the clamping screw. So this is just going to be the same as what we've just done pretty well. I'll just put a couple of clips in of it. It's just 2 turn the ends down to 8mm, and we're going to use the same process as what we did with the other part. So we're going to drill and tap these for 3/8 UNC. And why I hold these parts at the extremities of the jaw, if I was to hold them like that, and if there was any slight discrepancy, which there's a couple of thou discrepancy in these, it'll grip that one and not grip that one. And if I go to the extremities of the jaw, well, they're only spaces, so it's only, they're long there within a couple of thou of each other, it's fine. But if I grip them at the extremities of the jaw, there's enough give in the vise and I get equal gripping pressure on both parts. Now it's tight. Okay, so we'll get this centered up and drill and tap 3/8 UNC. And of course the part's not properly clamped unless it's had a bit of a taparoonie, just to seat it. And using the last word, we just re-centralise our vise. And that's good there. Just another method for centering over something like this. You could do it with an edge finder if you're that way inclined, or you can just drop your, make sure your scale is straight, drop your scale on it and watch what's happening over there. So I go down, see that lifts? So I'm too far one way, so I slowly bring it back. See the distance, the scale's not moving as much. Stop moving there, so I just bring it back. I just want it just so it doesn't lift. You turn the scale over. It just barely moves on that other one. So we can still go this way just a hair. Something like that. Turn the scale over. That's rattling on there. So I know if it's rattling, I know I haven't gone too far this way. So we're on centre there. Okay, I forgot to press record then. I've got a 10mm spot drill and I've gone in till the drill has drilled its entire width. So on the edges of the hole, we don't get a funky area for the tapping drill size, the tap drill to start in, and also the tap. So it does cut deeper at the rear and at the front of the hole. So when the drill starts, it has an even surface to start on. The other alternative, you could put a flat on there. So we'll drill now, drill and tap. So pilot drill, probably get away without using one, but 8mm is over the size of 1/4 inch, 6mm, so we will use one. And the tapping drill, 8mm. And tap the hole. Bloody VFD didn't like that. Okay. Yeah, the sooner I get this machine back onto 3-phase, the better, and get rid of that VFD, I'll be happy. Right, that's 2 more parts complete. So the old Archer tapping chuck did well. We still have to do the repairs to the clutch in it, but will be at a later date. So going in with that 10mm spot drill, you can see it's given us a really tidy entry to the thread versus the exit. So we'll put that to the top. We could put these in and do a bit of a chamfer on there, but I don't really think it's worth it. So yeah, going into full diameter, it's really cleaned that up. Right, on with the next part. So the next part's a series of spacers. Got one here, there. So they are these and these, which look like that. So it's a pretty well a replica of sort of what we've just been doing. Oh, excuse me. They have a hole tapped in the ends, similar to this one. So I'll knock those out off camera to save a bit of time because it's the same process. So these are the parts we've just completed. These pins, I didn't film them because it's exactly the same procedure as these parts here with regards to the ends. So these are both all turned down to a 7mm end. Alright, these had 8mm, and they have the same 5mm thread tapped up each end. So I'll just put in a couple of quick clips of the threading in the lathe, and then we'll move on to our next part. These are the materials left over so far. So we've got about 75mm 3 inches of the 19mm 3/4 bar, 25mm or an inch left of brass, which you need that to hang on to, so that's at minimum. The 5/16 8mm rod that we used to make the pins, I did run out of that. I should have checked the length before I started it. So I'm not sure if there was enough length supplied. Whether I just happened to get a short bit, I don't know. Lucky I had a little piece laying around anyway. But bear that in mind, I was using a pretty wide tool to chop them off, so that gobbled up a fair bit. So yeah, I should have checked the length. So, right, next part. And the last part. So we have the jaws to make. So we're going to get these out of the piece of aluminium supplied. So we're going to cut these V grooves. So there'll be a V groove cut all the way down, this one in the middle, and then a V groove across there and across there. And then we'll probably look at either cutting them in half or drilling the holes through after that, or we could do that first. Let me have a think about it. Okay, thought about it. So we're going to do the holes last. But this is a 25mm square 6061. Aluminum. Of course, if we brought it here in Australia, it would be aluminium. Now, we have to take it down to 22mm square. So if we put our hole in first, then we've got to dick around and keep the hole central. So we'll square the bar up, then we'll put the hole in. It's a bit easier that way. So I think we'll head to the shaper. That'll be okay. The front of the tool, the edge is getting lapped. That's hollow ground under there, but we have covered the edge. This is just a 400 grit lapping wheel, and I've got 1,000 and 2,000, and just got a couple of magnets and set into it. It's just a temporary measure this, as yeah, it's not ideal to be lapping on a lathe, but at the moment we have to. Yeah, so at the moment this lathe isn't being used as a lathe and she's pretty covered up, so this is my interim lapping station. So I use this on everything, so nice and easy just to quickly change the wheels. The only downside of the magnet system is all the crap tends to stick to the wheel, which is it's not that problematic, but yeah, it's not ideal. So, but for the ease of swapping discs from one to the other, it's yeah, I'll stick with it. So this is that same tool we've been using a fair bit in the shaper. Alright, for aluminium it is a little bit on the minimalistic side for, you know, back and side rake and that, but we'll see how it goes. I'm pretty sure we'll be fine. Yeah, not a glowing finish, so I might have to, well actually I would have expected better out of this tool. I might have to have a look and see what else I've got, and maybe we'll go for something more specific for aluminium. Okay, so I've changed the tool. You'll see the ripples that are in this one. I mean, that's a different tool from there. And that's the same tool as here. Now I grabbed another piece of material. This is supposed to be 6061, and I grabbed a known piece from my stock that I know is 6061, and I'm going to say this is most likely 6061 as we're getting very similar results, but what I did do, I ground up a special tool with aluminium angles on, yeah, for aluminium, and I sped the shaper up quite a bit, and we're just going to go with this finish here. It's should be quite acceptable for what we are going to do. So let's get our block set back up and get it down to size. So this was just ground up out of an old tool. I've only just ground the end of it. So she's got a lot of back rake and a lot of side rake, ample side rake too in there for aluminium. So we'll give this a go, and a round nose. So we'll continue with this. That'll be acceptable. So we'll continue on. We'll take some off the side here. We don't have to worry about putting a piece of wire in behind it or anything like that, because this piece is already square. Square enough, at least, for all the purposes we are using it for. I'm still keeping my faces up against the hard jaw though. It's rocking, it's on it, but it's, give it another tap. That's got it. Right, let's take another cut. We'll just take 1 millimeter off, and then when we go to do the other two sides is when we bring it to dimension. Okay, so I'll come down 1 millimeter. Lock the slide off, take out the backlash. Away we go. All right, we'll get this deburred and rolled over again. So we got 1.4 mil to come off this side here. So there's 0.2. That's 1.4 there. We'll just do it all in one go. Okay. We should be there. So that come up at 21.96. Okay, we're 0.04 millimeters under, but it's a clamp. So that's why we didn't bother too much about chasing precise dimensions. So the other side, we've got 2.4 millimeters to come off to bring it to size. I'm not going to touch our height. I'm just going to drop it back in and we'll just take that all in one go. Right, we should be on size, or thereabouts. $21.96, the same. Okay, we'll get this out. So the next stage is these two V-grooves. So what I'm going to do, or my plan is with this 90-degree tool, just come in and plunge straight down. We'll see how they go. They're only 2.5 millimeters deep, so I'm hoping we'll get away with it rather than have to come in from the sides. So I've just ground up this 90-degree tool. It just has a bit of a back rake or inclination on it. There's no side rake, so she's neutral across. There's no side rake whatsoever on it, as we plan to be cutting on both sides. If I had to put side rake on it, it would be useless for cutting on one side. So I'll pop this in and we'll see how it goes. The other funky tool that worked out very well, so that has some quite aggressive angles on it, but it worked well. I didn't want to chop the end off the tool and start again, because it's a waste of a good bit of tool steel. So we're only using a little bit. That's all we used, was a little bit of it. So anyway, let's get this one set up and see how it goes on this V-groove. So because I use the tool and cutter grinder to grind my tools most of the time, I only need to square up the side of the tool, and that will automatically bring the 45s into alignment here. So that's one advantage of a tool and cutter grinder. Especially with threading tools, you know, you can grind the tool angles. So all you need to do is set up the side of the tool and everything's going to be correct. So I'll just get this centered now over our mark on here. So we're centered over our scribe line to the middle. So all we have to do is come down 2.5 millimeters from there. And I'm going to slow the speed down a bit too. Drop it back to 40 strokes a minute. Okay, that's our groove done. So it's 5 millimeters wide and 2.5 millimeters deep. Yeah, I didn't realize that last clip, the old tool and the shaper and the lantern tool post was getting a bit close to the camera, and the camera started wigging out a bit. Okay, so now we've got the same groove to do, but the opposite way around. So we just need to take a small clean-up cut down the face. That'll give us a datum line then we can measure back then to the centre of the cross grooves and vice same on the other end. And using the grinding vise is just a quick and easy way to get our 90-degree rotation. So we are cutting up against the fixed jaw, so should be all right, no problems. And also, because we are cutting down on a vertical surface, the clapper is swung away from the angle. So on a return stroke, as the clapper lift lifts the tool, it lifts it away from the face that we're cutting on. And so we're going to use the machine's auto power feed to do this. And I think a lot of shapers have a similar arrangement. So it has this ramp which operates this lever, and when you engage it here on this knob, rotate this knob 180 degrees, it clicks in the mechanism inside and automatically advances the down feed on the return stroke. See the handle automatically feeding down by itself. Okay, so we don't need this tool any longer. We can take it out. It's just a big old lump of it's Rex 95. And camera won't. I've just ground it to just a generic tool that I can use in multiple applications. I can face both sides of a part. We'll try it out later on another job, how it cuts on the flat face on the bottom. Let's get our other grooving tool set up now. Well, winter's knocking on the door now, so we've had a couple of days of rain finally. We haven't really had rain since December, so even the back paddock just in front of that tree line way down the back there starting to green up. You probably get 5 blades of grass grow for every 1,000 weeds. Yeah, that's what the rain does, brings out all the weeds. Oh, we've got a bonfire there, we'll probably light that up next weekend. As it's burning season again, all the excess wood that off the trees. So, back to our clamps. So we're down to depth and our V grooves have intersected at the bottom there, so we'll do the same on the opposite end. Right, that looks good. We'll take it out the vise. So we have an 8mm hole that we have to drill in either end of this block. When the blocks are chopped off, that'll put a hole completely through the part. All my vices are tied up at the moment. So we're just gonna, just a 1, 2, 3 block in a parallel with it clamped up into the corner position. So it's just a matter of indicating it in here. Pick the low, we're on 0, come up, half a turn. Same deal, pick the low, which is on 0. Now we are indicating off center, and that's to miss our V groove there. So this way we're right. So we'll come up. So we've got to move the table across. Out there, and I'm a thou out here, so I'll just adjust that. And likewise we do the same here, picking up on the 0 on the low. Just come up half a turn, bring it back down. And same reading. So we're on center, so we'll get a spot drill in now and put our dimple in for the drill bit. So I'm just going to go in with a 5mm pilot drill, and then we'll follow it up with a 5/16 drill. The drawing says 8mm, so we'll see how the 5/16 goes. You want a little bit of clearance on your pins, and the pins are 5/16. Well, they're closer to 5/16 than 8mm. I'll go and get a pen and just check that to see how it goes. We can always put the reamer through if required. That's worked out alright, that's quite a neat fit in there. Alright, we'll flip it round and do the other side. Actually, I'll just put a chamfer on there first. That will do it. So the other side will be the same, so I'll do that off camera. I'll break this setup down, I'll set it up exactly the same and do exactly the same thing. The only difference is I won't need to centre the part, as we've got good hard stops here with our 1, 2, 3 block and parallel strip. The lubricant I was using, it's remnants of an old can of CRC that had lost its puff. So I popped a little hole in it and drained it out, and it's probably a more efficient way of using, not CRC, sorry, WD-40. It's probably a more efficient way of dealing with WD-40 than spraying it everywhere. You know, spraying it everywhere keeps everything lubricated, but yeah, someone commented the other day the fumes are probably not the best for you. So yeah, I'll bring you back when the other holes is complete. Right, that's our hole all of the way through. Now we're going to look at cutting them to length. Okay, we just have to correct a bit of a snafu here. It's not a biggie. Okay, so when we cut these two cross grooves, I had it in my mind that the blocks were 22 millimeters wide, but they're actually not. There's 2 at 13.4 and 2 at 19.9. And also had it in my head that there was only 2 blocks. You know, we are making 4 clamps, so we need 4 blocks. So what I've done is worked out the dimensions starting from the bottom, where the groove, the position for the new V groove, 35.9 off one end and 29.4 off the other. So using our vernier height gauge, and so we don't make any more errors, I've marked out, so we have a groove where that half scribe line goes there and another one down there. I've also marked on the rear, these are all of the cut lines, so that's a space we can cut, that's a space we can cut, that's a space we can cut. That'll give us 1, 2, 3, 4 jaws. This is the error with the V groove, so if we machine that down to that scribe line, we're back good. And likewise, there's about a millimetre, 1.05 millimetres to come off that end. What have we got? 4.3 to come off that end. So, using the vernier height gauge and some absolute measurements, we are right back on track. At least we know now we've got good guidelines where we're going. So I'll hop back in the shaper off camera. I'll knock in the other 2 V grooves, and then what we're going to do, we're going to head over to the lathe and we'll chop these all off to length in the lathe. Actually, I think I had it in the back of my mind too. I was only going to do V grooves on 2 of the blocks and just have 1 block on each one as a plain block, but we'll stick to the drawing. So with our part mounted in the 4-jaw with some protector strips underneath and a gauge pin to clock off, we can now put a tool in, face this side back to this scribe line, and then we can put a parting tool in, and we've got this distance here to split to chop our first block off. Then we can face back to that part scribe line there, and then we've got another one to part off there. I opted to do it in the lathe as it just seemed to be the easiest, most logical way to do it. As they're quite short pieces, I wasn't really inclined to grab a hacksaw or mess around and try and do it in a bandsaw. So what my plan here is to come in with this tool here, and we can just plunge straight in and part these off. The tool is a fraction narrower than our 5mm parting width. We're just about 0.1 of a mil under. So what I'll do is I'll just take a trial cut through just shy of the line and just see how this tool runs. Okay, well, that worked rather well, so we'll take it to our full scribe line now. Looks to be about there. Fraction more. Another couple of thou, that way we can split that line in half. Okay, we're there. So I'll just get a countersink set up, and we'll I'll just use my deburring tool, which I'll be back, which was on the milling machine where I left it. So finish width is 13.4, so we can zero the end of our tool out on the part. That's fine, cigarette paper. And wind in with the compound, 18.37 millimeters. That's taken into account the width of the tool plus the 13.4 width of the part. Right, we've got through all of the parts on the drawing, so I guess now's time to assemble a clamp. So there's that many different ways you could, go about the operations and steps for machining these parts, depending on what equipment you've got, of course. Would I do anything different? Probably the only thing I would do different when it came to the blocks, I'd be like, obviously this was a kit, so they give you enough material for each part. But if I was making it out of my own materials, the blocks I would make out of round bar. That way I could have had something to grip onto when I was cutting the blocks off. I wouldn't have had to keep repositioning this in the chuck. Because, all the square and the grooves, would have been quite easily done on the round groove there, regardless if it was in the shaper or the milling machine. We could have still slotted that way into round bar on a shaper. We just would have had to do a relief groove for the tool to drop into. It's all doable. but it would have saved a lot more time cutting the blocks to length. So let's get this thing assembled up, shall we? So here's our assembled clamps. So they're a very neat fitting clamp, like they don't have any slop or play anywhere. I guess if you've done everything right, your jaws will line up at the end of it. So let's there's no play in them. The jaws move. We'll go and try one out, shall we? So the exercise in building these clamps is a very good experience for like a new machinist, you know, hobby machinist, or someone just wanting to learn a bit about the game. It'll give you a really good insight into how finicky you've got to be with sticking to dimensions. Otherwise, if you don't, you'll either be in a position where these are really sloppy or they won't go together. So let's go and try one in the Bridgeport. So traditionally I've always used this style of parallel toolmaker's clamp. So feels nice and solid. It's not spongy or anything. Actually feels really good. Yeah, and I've got a fair bit of weight on that, so that's gripped that really well. So all in all, for general clamping, I think they'll work out quite well. Well, there you have it. We now have two really good sets of 75mm clamps. I think the process went rather well. One thing I must say is you do need to be really finicky on your sizes, because if you're not, when it comes to a final assembly, you're going to be in all sorts of pain. So that's just take note of that, and you'll have if you choose to buy and build the kit, you'll have a good tool, or a good pair of tools. Anyway, hopefully you got something out of it. That's just a different way to make them, my methods. So yeah, it all went well. So anyway, cheers, thanks for watching, and hopefully catch you in the next video, where I think we're going to be back on the JFMT lathe. So cheers.